Hey guys, welcome to this particular session. And in this video, I'm going to be explaining the core Python logic for anybody who is a machine learning beginner. So I'm just going to keep this session very simple, just like we are running our series. And I'm just going to put some kind of hands-on practicals, but I promise it to be a very enjoyable session, and that one will definitely find plenty of value inside of. Now, I'm just going to go back to the first slide again. So we're going to be talking about some of the Python logic and, some of the operators, comparisons, and conditional statements. So this is just a very simple session. And if you are actually getting started with programming in Python, you understand that as a programmer or someone that is a machine learning engineer, logic is something that really matters, okay? And it's something that you're really going to apply very largely on the part of your machine learning journey during your programming course. And yeah, basically on a lot of things, okay? And yeah, so when we say logic really matters in programming, I'm going to actually explain it. I'm going to open my virtual environment. I will share some kind of I'm going to run some syntax to make it very scintillating. So machine learning models is all about decision making, and basically what we are trying to look at now is how can we now apply that code. All right, how can we be able to, simulate the decision-making process while we are executing code on our terminal? Probably we are running it on our Jupyter Lab or Jupyter Notebook or maybe any kind of interactive Python notebook or environment. Now, one of the things we're going to actually look at are operators, okay? And what are operators? Operators are more like special symbols in Python that, that tells the computer how to perform some kind of specific actions on values or variables. So just think about that as, kind of verbs in programming. So I'm just going to go into practicals. I'm going to open my Python. Sorry, this is my virtual environment, VS Code, more like an integrated terminal where I'm going to show some kind of practice. I'm just going to close this. I don't know why it's opening several virtual environment. So I'm just going to open a random folder. I'm going to create a folder and I'm going to call this practice, maybe again. Yes, so I think that's fine. Okay, we're trying to, okay, we didn't save the folder. We'll just, so you create a new, so you call the folder practice, machine learning. So let me call it machine learning, okay? So basically we're going to be using this folder plenty of time in our machine learning journey. So I'm just going to save that. And, excuse me, it's going to open this particular interface. And I could just name this machine dot. So if I use the extension machine.py, it's going to create a Python file for me. I could decide to create another one. I'm going to call this pv.interactive Python notebook. I want to be sure I got that correct. Okay, yeah, I did. So by default, this is going to create a Python notebook. And remember, that's a Python file. I could just run print welcome to programming. Okay. And to run it, I'm going to just click here and I'm going to run it. And that's it. So this is it. Welcome to programming in Python. Okay. Now, now what we are talking about now is I'm just going to go back to the slide. This same thing also applies in, it also applies here as well. I could just select an environment, maybe Python 3 point whatever thing, and Now, basically, what I'm going to like this is where we usually run machine learning code. This is the interactive Python notebook. This is just a normal Python file. Now, the difference between this and this is that you see that when I actually hit this, it's printed on the integrated terminal, right? But when I actually print here, let's say, for example, I print something like, I print welcome to programming in Python. Okay? Shift enter, that's what I'm going to use, and it's going to just print it. So what this particular interface helps us to do is that we can run something here, we can be running something on this tab place, can also be running something, like it just gives us that kind of flexibility, right? So that is that, okay? So which anyone, it all works. And this is Python, this is also uh, machine learning is written mostly in Python. Now we're going to just go back to data. So when we talk about operators now, okay, so we are talking about mathematical symbols like plus, minus that we use in our everyday calculations. So you can see them here, plus, minus. So we can actually have stuffs like maybe I could see maybe age is equals to 78. Maybe weight is equals to maybe 89.5. So I'm just going to change this to height. Could be 1.7, 1.8. Remember, all these are floats, okay? We talked about that in our last session. So I could just say BMI is going to be equals to, I think BMI is calculated as height. Okay, I didn't spell. Okay, I'm going to say it's height over, I think that's width over height squared, okay? So width divided by uh, height, that's squared. So this is it. Okay, this is how it represents squared. And I'm gonna print I'm gonna print the BMI of the patient is, okay, I'm just gonna semicolon, comma, BMI. I'm gonna run that. Okay, I didn't use this part. BMI is not defined. Okay, I mistakenly spelled this wrongly and I've corrected that, okay? So I'm just going to run it. So this is it here, right? So the BMI of the patient is this. You can see that here. So now what we are trying to explain here now is very simple. Let me just clear this so that I can be able to see all of this. I just want to keep it clean. I'm just going to run it again so you can see it and it's clean. So now this is it. Now the first line was printed. Welcome to programming in Python. I could just comment that out. And if I run it again, you still see this. So you see that the BMI of the patient is this. Now what this means now is that you see that we performed what we call what? Arithmetic operations. Okay. So these are what we call operators in Python programming. So the same thing can also apply here. I could say maybe x is equals to 7, y is equals to maybe is equals to 3, print maybe x plus y. I could say print uh, y minus x. So print y divided by x. So all of these are all what we call what? Operators. These are what we call what? Operators in Python. And but there's something we are going to look at while we are looking. Then the next thing might be arithmetic operators, which I've just explained now, can have a is equals to b is equals to 5, a plus b, a minus b, and all of that, okay? So the same thing also applies here. Test 1 could be this, test 2 could be this, average test could be, okay, test 1 plus test 2 plus test 3 divided by 3, print average, okay? So that works. We could just show an example of that. We could say, okay, maybe the maybe we could do something like mm, microbial load, okay, for patient 1. Now you see that you see that I'm using a proper naming intention. This was something we explained in the last class, okay? Let's say 72.1 microbial load for patient 2 is 82.3, and the microbial load for patient 3 is equals to 27.9. Okay, now you're asked to get the average of this. Now you're going to perform operations, right? So you're going to say print, then you now put microbial, or you can say, instead of saying print, you can say that the average, you assign it to a variable. The average is microbial load of patient 1 plus microbial load of patient 2 plus microbial load of patient 3. Okay, so we can wrap this with a bracket because if it's academic, that's what you're going to do, divided by length of, okay, we didn't store this in a list, sha. So I'm not really going to just see. I don't think I'm going to use length, okay? Let me just make it simple, divided by 3, right? So this is 1, 2, 3. And then we can now say print average. And that's going to print. So this is the average, okay? So these are actually some of the operations we're going to be performing. So I just want to put it to you that if you really want to get good with this, you need to practice again and again and again and again and again and again. And you will really, really be very conversant with the syntax. So this is just a very simple stuff, okay? I can decide to add comments here. Comment, what do you mean by comment? I'm going to put a pound sign, then I want to write, this is where I will print the average. Okay? So you can come here and you say, sorry, you can come here and you say, this is where I will compute the average math. So what comments are is that even if when we run this now, you see that the comment doesn't, Python, when it's running the code, it goes straight. It's going to ignore this. But if I try and remove that sign there and I run it, it's going to say syntax error because this thing is no longer a comment. But to be a comment, I'm going to highlight it and I'm going to press Control backslash, okay, on your keyboard, and it's going to comment it out. Or you can try to come in front and you put a pound sign, and that still works fine. Okay, so that's what we call comment. And this is actually how we show operations, okay? So you can actually come here and put a comment here. As long as you're putting it anywhere the pound sign starts is where the comment will start reading. Here you can see this is for patient 1. So that whenever somebody wants to read your code, the person will understand. I'm going to put the pound sign here and say patient 2. And I'm going to come here again. I'm going to put the pound sign here again. I'm going to say patient 3. Okay, if I run it, everything still works fine. But if I try and put the pound sign here at the beginning here, it will comment out this thing automatically. And if we run it that way without defining that variable, okay, it's going to throw up an error. So these are some of the operations that we have. So we're going to actually look into other types that we have. We have comparison operators. We have equal to, not equal to, greater than, less than. I'm going to talk about this in a jiffy now, okay? Now, when we say 5 is equal to this, it means it's true. 5 is equal to this is false. If we want to say the not equal to in Python, we use the exclamation and equal to, right? Single exclamation. So if we want to use greater than, we use this, that, greater than or equal to. So these are comparison operators that we use in making logic. Now let's take an example here now. So I could say here, x is equals to 7, for example. Maybe x is equals to 100, y is equal to 6. Now let me say, print watch x equal to y. Now let's see what it's going to print. I'm just going to expand this. Okay. Now let's see what it's going to print. Okay. Now we're going to print shift enter and it's going to print false. Now, why did it print false? Now, the reason why it printed false is because x is not equal to what? Y. So each time we want to use the equality sign, we use what? Equal to. So this means what? Equals to. Okay? If you use a single equal sign, it means what? What it means is what? This one means an assignment operator. So this is what we use in assigning containers to data types. So this is what we use in assigning variables. All right. And so you may like come and change this into equal to is because it's now another thing. I'm trying to say that x is equal to 100. So it means that I've defined x somewhere to now say it's equal to this. Right? Now watch, if I want to use not equal to, I'm going to say not equal to. So this means not equals. So, okay, so I'm not really going to spell this much out because it's quite self-explanatory in my notes. And I'm just going to run this. It's going to return true. Now, if I do something like as type int, it's going to return with, uh, let's put it inside of this. Okay, all right, okay. I think I found where the thing is coming from. All right. And this is something that we're going to use mostly in machine learning. All right. So, but we can always get the type of all of this. Okay. So we can also use another, excuse me, another operator is less than this, greater than that. Basically everything is already well explanatory, and just understand that it's going to return Boolean values. All right. So for example, here you can have okay, so I'm not going to take that out. I could say um, y equal maybe I'll say is greater than or equal to x. Maybe I could say g is equals to this. All right, I'll also print g. It will give me false. Now, why did it give me false? Because y is not greater than or equal to x. Y, first of all, it will check, is it greater than x? No. Is it equal to it? No. So it's going to print g. So now you see that g now, I now assign g as a variable to it. Then I can now come here now and see something like maybe g is equals to something else and all of that. So this is what we call what? Comparison operator. So there are a lot of them that we use in what? Uh, in machine learning. So that's just basically it. You can compare this. Is it greater than this? What's the result? It could be true or false and all of that. So it's going to be really, really, really very, very massive during our explanations here in machine learning because probability, every comparison in Python produces a Boolean value, okay? So it's important for us to understand. And it can be either true or false. There are no strings or numbers. They are just a special data type that represents logical states. So those are actually some of the things you need to understand. Now, just like we did yesterday, uh, with this particular expression now, let's try and understand what type of variable is G. Let's say type of G. So it's going to tell you it's a class of Boolean because this is going to return a Boolean. All right. Uh, if you do something like as type int, okay, it's not going to work because this is not the numpy. But what you need to understand is that this is a what Boolean value because it returns true or false. Okay, yeah. So there are actually other logical operators, true or false, combining conditions. I could say something like is maybe I could do like h is equals to 45, j is equals to is greater than or equal to 78. Then I'll now come and say p is equal to maybe h not equal to j. All right, so just get the logic here. I just want to be sure. Say print p. Okay, so j is not defined. Okay, yeah, this is it. All right, then so it will say true. Okay, now I can also nest this now, right? I can nest p and g, right? I can say something like g. Maybe I can now say something like z is equals to p equal to g. Let's say print z. So to say false because p has its own full condition, g has its own condition. So this is just like saying this and this. Okay, so one of the things we need to understand is that there could be a time we might be working with a health data set, something like, I'm just trying to look for an example. Maybe we're trying to understand, okay, let me just go into deep, okay, let me just something like malaria is equals to, maybe let me have a list, present, absent, present. Okay, then I'll now see test, maybe typhoid. Is going to be absent. Maybe let me just use a word like positive, negative, and positive. Now, what we're trying to say now is that it is possible for us to say if, maybe I'm just trying to go advanced now, if uh malaise, if in malaria, if in malaria, or maybe we'll say if present in malaria, print malaria is present, else print that is so there is no present. Okay, so if present is there, so this is because this is uppercase, so I'm going to change it. Malaria is present. Okay, now so basically what we are trying to say now is that based on all of these conditions here, there are possibilities for us to make some kind of statistical comparison. I'm going to show you something now with this example. There's a reason why I just initiated this particular example here. So these are actually further information on logical operators. Uh, the hierarchy age is this, has fever true, fever threshold is this, okay? So we can say that high risk is if age is greater than fever threshold and has fever. Okay, then print that it has risk, okay? So this is just a very simple syntax that we can apply here and that's it. So when we print that, it works, it's true. So it's just very simple. You can come up with a lot of them, and definitely when you're going to be working with data sets, these are some of the syntax you're going to be working with to understand, particularly for you to start programming in Python. So I'm going to actually do some kind of slight introduction to conditional statements, more like decision-making structures, and Python checks if the condition is true or false. Based on the result, choose which code to run and run the appropriate block of instruction, okay? So we have what we call the if statement in Python. So think about the if statement as when you open your phone. Back then, I used to look at it this way. And when you click on a button, it will return something. If you don't click on a button, that thing will not happen. Or maybe something else might happen. So that is just what you need to think about whenever it comes to if statement, all right? Here you can say resistance is equals to true. If resistance print, consider alternative antibiotic, okay? So that is just one of the examples that we showed here, all right? So we can have malaria score is equals to 1,000, okay? So I'm going to write if malaria score is greater than um, maybe 500, maybe do something, right? Malaria score is very, very high. So when I run that, it's going to print that malaria score is very, very high. So this is just what we call a condition, okay? A condition. So let's look at this particular example here now. We can use that condition. We can actually apply it here now, okay? So we can see that if age is equal to, now is equal to fever threshold. Now, each time, anytime you use the if statement as a function or whatever, you need to make sure you leave a colon at the end of that write-up, okay? You must leave a colon there. Print they are equal. Now, if I just run this, right, what will happen? Nothing will really print. Why? Reason? Because they are not equal. So I didn't ask it to do anything. I only asked it to print they are equal if they are what? If this is equal to this. Remember that I already explained what these operators are. I already explained that it means equals to. That means you're trying to say that this thing contains the same number of things with this. It's different when you use a single assignment operator. If you use a single equal sign, it means that you are trying to assign age to be that thing. You've created age as a variable to assign it to something. But when you use the double equality sign, you're trying to now make a kind of comparison, and that's what we're talking about today. Now, let's hold on with that and look at the next slide, what it presents. Okay, because we said that this is, if it begins with a conditional statement, basically Python uses it to group code that belongs together. The indented part of the indented part line is part of the if block. Without proper indentation, it will not work and your code will not run. Now let's look at adding an else statement. Now you see that first time that we ran the code, it didn't run. But now in a scenario whereby we now add another switch statement or something, okay, we can now add something like else here, but that it now will come down. For the else statement, we're going to come down. So we're going to print they are not equal. So you see that because when we left the else statement, it just did not print anything. But because we've now given it consideration for the else, now it's now printed that they are what? Equal. So we also have what we call the if-else statement. And we can actually use that if-else statement is more chained. We could say A is equals to 67, for example, B is equals to 89. And we'll now say uh, if A is equal to B, then we'll now say print they are equal. They are equal. Now watch you. Now I will now say elif. Now, what does the elif mean? Else if. Else if A is greater than, is maybe greater than or equal to B. Now watch another condition. I'll say print A is greater than B. Now we can now say else. We can also give another else if statement, okay? Can have as many as possible. Else we'll say print B is greater than A. So you see it, B is what? Greater than A. So it first of all passes through this condition. If A is equal to B, print this. Does it satisfy this condition? No. So it will step down to the next condition. Does it satisfy this one? No. Then the next thing, it will now come to the last one, which is this. It will now say, okay, this is what it means or implies, okay? All right, so that is how the if-else statement work. So first check, it checks the if, maybe in this case, if Mike is greater than 4, print hugely resistant. If else, if Mike is greater than 2, print moderately resistant, else it's susceptible. Okay, so we use this popularly in machine learning. So the indentation is very, 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 very important. It's true too. You will observe that in my code, each time I use this semicolon after a function, there's always an indentation, okay? In this scenario now, the reason why there's no indentation is because there is, of course, you see print here, the names are equal, and this as well. So the thing applies, it applies to more like all functions, in Python. So indentation is very important. If you don't put the indentation, it's not run. It's going to throw up an error. All right. So the real world application or of this logic could be to collect my compare threshold, assess severity, recommend action. So there are several tons and thousands of Py scripts where we are going to write use our if-else statements, logical operators, and all of that. So I believe it's something one should get, braced up for. So nested conditions too exist, okay? So what do you mean by nested condition? If patient age is less than this, print this. If has chronic cancer, again, you now print this. But else, if it doesn't have chronic cancer, then print standard monitor recommended, which means it satisfied the what? The first part. So let me just show an example of a nested condition. Now let's say, for example, maybe school is equals to logis. Position in class, probably second. Okay, I'm going to write this way, second. Now I'm going to say something like if school is if school, for example, print 9 school there, okay? If position is maybe let me make it this way. If position is not equal to second, Mhm. Then print, you didn't do well, else watch the intention. I seen all the intention that we use in programming. Then you print, else you print, maybe you are really doing well. Now, what does this mean? Now, this means this is a nested if statement. So this is the first one. If school, you should do this. Now in school there, if position is not second, print you didn't do well and all of that. So we'll go just run this. Logic is not defined. Okay, we didn't put a string column. Sorry. All right, so let's see if that runs. Okay, school is not defined. What's happening? All right, so I've actually typed that correctly. So if school, it means what? That means if school, I could use another one. If school is equal to logis, is still the same thing. Okay, it's still the same thing. Okay, it's still the same thing. So what it's going to do now is, it's going to print you are really doing well. And that is how it works in Python. Okay, all right. So there are a lot of mistakes a lot of beginners do make. First of all, you use the equal to sign wrongly. Um, you feel you feel you're just messing up with your indentation, wrong Boolean variables and all of that. So I believe this is quite very explanatory. So I'm just going to be leaving you with some kind of exercises. Write a conditional that checks if a patient's age is greater than 50. Check out this resistance status that won't like it to print and combined conditions as well. So a lot of these actually matter in machine learning because of decision tree, classification threshold, evaluation relies heavily on comparison. And yeah, these are actually some key takeaways. You need to make sure you get very strong with operators, perform some kind of activities, conditions, enable decision making, logic, and all of that. So this is actually going to be that for tonight. I just want to say a very big thank you to each and every one of you that found this video very useful. Do like and subscribe to this channel, and I'm definitely going to see you on the next one for the next machine learning model training. Okay, so cheers and have a very wonderful time.